Day 3 of solving LeetCode problems until I'm hired by a FANG company. Today we're gonna solve 1791. So we got ourselves here an easy problem. Find center of star graph. There is an undirected star graph consisting of n nodes labeled from 1 to n. A star graph is a graph where there is one center node and exactly n minus 1 edges that connect the center node with every other node. You are given a 2D integer array edges where each edge indicates that there is an edge between the nodes ui and vi. So return the center of the given star graph. So here we have edges. The common element here is obviously 2. I believe that is if there is an element that would repeat the most amount of time, then that should probably be the center of our star graph. The first thing I'm thinking here is that, again, the element that repeats the most is probably going to be the one that is going to be the center of the star graph. So indeed, we could create here a hash map or like a dictionary, right? In which we would just have the count of all of the elements. And whoever is the maximum value that repeated the most, then that is going to be the value that we return. In this case, 2, we're going to have it 3 times. But if we create a hash map, we could end up having a lot of added space complexity. So what we could actually do is, since we have a star graph, and there is one center node and all of the nodes, all of the n minus 1 nodes will be connected basically to the center of the star, then that means that the center should be in every single one of these elements, right? So we could probably just have left equals 1, right equals 2, and then we would iterate to the next one, and whoever is the one that we have here, like we have 2, if 2 is present in left or right, then that means that that is the center of our star graph and we should be able to return that element. Having said that, we can start coding that up. I'm going to leave that right there. And well, we're just going to need a left is going to be equal to edges 0, 0, right edges 0, 1, and then we're simply going to check the next one. Let me just actually make it this way. So if edges 1, 0 in left, right, then return that element. Else return edges at 1, 1. And that really should be it actually for this problem right here. Let's see if this works. Okay, so the 2 test cases were accepted. Let's submit this. And okay, there it is. So our solution beats around 55% and memory-wise around 20%. That is a little weird, but still I'm very satisfied with the solution because the time complexity is basically constant time. So very happy with that.